Welcome to TOC class. The concept of automata theory contains five categories. One is alphabet. Alphabet is used to help to form strings. Collection of strings are called languages. Languages are framed with the rules called grammar. The diagrammatical representation of those rules is framed with the help of graphs and trees. And few operations can be performed on strings and languages. So we are aware of those concepts. And the second part of the notations is formal proof. So proof means try to find a solution in a sequential manner. So that is called as proof. So here there are four different formal proofs are available. One is deductive proof, reduction to definition, other theorem forms, and theorems not appear in if-then format. First we'll know about a formal proof. So what is a formal proof? Formal proof is also called as a derivation. So this derivation contains a sequence of sentences in it. The sentences may be English sentence with some conditions are available. So each is an axiom followed by rules of inferences. So if you write a sequence of sentences, those solutions of sequence of steps are known as deductive proof. The same set of sequence of steps which are all implemented in an iteration means that is called as inductive proof. So proof contains two major categories. One is deductive proof and another one is inductive proof. Only sequence of steps are available means this will be solved in deductive proof. If it contains some iterations in it, that will be called as inductive proof. Let us discuss about deductive proof. Deductive proof consists of a set of sequence of statements. So each statement contains true value. So how the true value can be formed? The true value which leads to some initial statement in a particular sequence. So those initial statements are called as hypothesis. Those hypotheses can able to find a conclusion. So it will be written as hypothesis implies conclusion. The generalized notation of deductive proof is if H then C. So here H means hypothesis, that means condition. C means conclusion. So this is the generalized notation of deductive proof. So how can you able to solve deductive proof? Let us discuss. The first example, if x greater than or equal to 4, then 2 power x greater than or equal to x squared. So they are giving only this statement. We should prove that whether this statement is true or not. First, let us discuss whether generalized notation is available. Yes, this example contains a generalized notation if H then C. So this statement is a generalized form. H means hypothesis. What is a hypothesis? X greater than or equal to 4. That is the hypothesis. The initial value of hypothesis is 4. So if you substitute x equal to 4, then what are the another possible way of substitution of H? X may be 5, x may be 6, but the basic initial value should be 4. Then the conclusion will be possible. What is the conclusion? 2 power x greater than or equal to x squared. So let us discuss how to prove it. So now first we take H is true. So if you take H is true, whether the answer for x may be 4, 5 or 6. Let us discuss. If you take x equal to 6, substitute the same answer for the conclusion. This is the conclusion part. 2 power 6. What is 2 power 6? It is 64. Greater than or equal to 6 squared, that is 36. So always 64 greater than or equal to 36. So if the hypothesis is true, then the conclusion is true. So it is one way of proving deductive proof. What is another way? We are taking hypothesis as false. False means you should take x value as less than 4. For example, I am taking x equal to 2. So if you substitute x equal to 2 at conclusion part, 2 squared is 4. Here also 2 squared, it is 4. If you take x equal to 1, 2 power 1 is 2 greater than or equal to 1 power 1 is 1. So if hypothesis is false, the conclusion should also be false. So this is the deductive proof. Let us discuss the second example. If x is a sum of squares of 4 positive integers, then 2 power x greater than or equal to x squared. So in which the hypothesis is the lengthy one. So here they will give the condition. What is the condition? X greater than or equal to 4. They are giving a simple way. In the second example, the hypothesis is the lengthy one. What is the example? You should sum up the squares of 4 different positive integers. Those sums is defined as x. Then the conclusion is same. So let us discuss how to prove this method. So first we take the first statement. What is this first statement? Sum of. So sum of 4 different numbers. So A, B, C, D are 4 different numbers. Sum of squares of those numbers. So A squared, B squared, C squared, D squared. If you sum up all these 4 numbers, you are taking the value as x. This is the given hypothesis. What is the condition? Another condition is positive value. So A, B, C, D value should be greater than or equal to 1. This is also given. If you take A is greater than or equal to 1, now what is the value of A squared? A squared is also probably greater than or equal to 1. Like that, all 4 variables value should also be greater than or equal to 1. So this is based upon the arithmetic property. And the next one is, if you substitute A, B, C, D with the minimum value 1, so it is 1 squared plus 1 squared plus 1 squared 1 squared. So the basic initial value is x is equal to 4. Now I am taking A, B, C value as 1 and D value as 2. What is the answer for x? X means 1 plus 1 plus 1 plus 2. So 4 plus 3 is 7. So only possibility is either x equal to 4 or x equal to 7. Like that, the answers may be varied. So the basic initial value of hypothesis is x greater than or equal to 4. So this fourth condition is already discussed in the first problem. So this is the first problem answer. If x greater than or equal to 4, the conclusion is true. The same conclusion is given for the second one. So we already proved the x equal to 4 concepts. So the same answer is applied for the second problem. Likewise, the second problem is also available in the formation of if H then C format. So we can prove it is a deductive proof. And the second one is reduction to definition. This is the second type of proof under formal proof category. So if you are not aware of how to start a proof, then we can able to convert all the terms of hypothesis. So let us discuss how to solve this reduction to definition. They are giving the example. Let S be a finite subset of infinite set U. Let T be the complement of S with respect to U. Then T is infinite. So how can you able to solve it? If it is a finite subset, so finite subset means that number of elements available in the set S is countable. But it is a subset of what? Infinite set U. So infinite set means the number of items available in U is uncountable. So this is it given. And T is a complement of S. What is the meaning of complement? What are the numbers available in S that will not be appeared in T? So if you take S intersection T, the answer is pi. That is the meaning of complement of S with respect to U. So S is a finite set. T is a complement of S. So the elements available in S is not available in T, but S and T are subsets of U. So U is infinite set, S is a finite subset. So other items from S to T is probably infinite set. So this will be proved. So here what are the hypotheses? I am taking hypothesis 1 as S is a finite subset. Second hypothesis is U is an infinite set. Third hypothesis is T is a complement of S. And fourth hypothesis is T is also a subset of U. So based upon this 4 hypothesis, I will prove the conclusion as T is infinite. And the third part is if then format. That is, what are the other possible way of writing if H then C form. So instead of writing if H then C, we can able to write the sentence as H implies C, H only if C, C if H, whenever H holds, C follows. Otherwise, if H holds, then C follows. In this 5 different way, we can able to write the statement. Here example, the given statement is in if H then C form. So if H then C form. So other theorem form means we can write the same sentence in this 5 different methods. So how can you write this? X greater than or equal to 4 implies 2 power x greater than or equal to x squared. Based upon the second one, x greater than or equal to 4 only if 2 power x greater than or equal to x squared. So the same statement can be rewritten in this 5 different categories, but the meaning is same. So this is under other theorem forms category. And another formation is if and only if. If and only if means we should prove 2 categories. That is, first condition means if A then B. We should prove the first formation. Second formation is if B then A. If those 2 statements are same, then only we can able to say the statement as A if and only if B. So this is the example for the real one. And the last deductive proof category is what are the problems, theorems that is not in if then format. Few statements which cannot be written within conditions, but it has some meaning in it. For example, sin squared theta plus cos squared theta equal to 1. There is no hypothesis in it, whether it is true or false. We should take theta value as 0 or theta value as 30, 45, 60, 90 like that. So I am taking theta equal to 0. So sin 0 value is 0. So obviously sin squared 0 is also 0. Cos 0 is 1. 1 squared is 1. So LHS part and RHS part is same for theta is equal to 0. If you are taking theta equal to 30. So sin theta value is 1 by 4. Sin squared theta like that. Cos theta value is 3 by 4. Like that the answer will be same. So all the answers will be same for theta is equal to what are the hypothesis? This is a hidden hypothesis. For theta value 0, the answer is same. For theta value 30, the answer is same. For theta value 45, the answer is same. Like that, the same theta value will be taken as hypothesis. So there is no direct hypothesis is given. We assume the hidden hypothesis. So this is a theorem, but it is not in if-then form. We can also prove it. Other proof can be discussed in next class. Thank you.